Hi, in this video, we're going to talk about how to solve exponential equations. Now, let's get started. So before we talk about general strategy, we're going to look at a few examples here and how to think about each questions. Now, basically, if you can see an equation where you can make them the same base, so you can see 4 and 256. 256 can be 4 to the power of something, right? Now, so the general strategy for this question is you're going to trying to make the same base of 4. Okay. Now think about, so I have 4 to the power of x, I write on this side. Now think about 256, what is that as 4 to the power of something? So 4 times 4 is 16, 16 times 4 is 64, and 64 times 4 is 256. So this one can be written as 4 to the power of 4. So 256, write that as 4 to the power of 4. Sorry, 4 to the power of 4. Then you're going to, once you have the base on the left and on the right, 4 and 4 can go away. So you get x equals 4. So with the same idea, in similar type question, the base is 3. So you're going to make 81 as 3 to the power of something. So 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, which is 3 to the power of 4. So you're going to rewrite 81 as 3 to the power of 4, and you're going to keep 3 to the power of x minus 1 equal. Once you've done that, 3 and 3 cancel out themselves. X minus 1 equal 4. X will be 5. All right. And on the last example, I pretty much do the same thing. So what I have here is 3 to the power of n minus 2 divided by 9 to the power of 2 minus n equals 27. So I'm going to make the 9 and the 27 to the power of 3, right? So what I have is 3 to the power of n minus 2, I write again. And then 9, you're going to write as 3 squared. And then to the power of 2 minus n equal 27, you write that as 3 to the power of 3. Now, what you do next is you're going to expand the denominator, the bracket out. So 3 to the power of n minus 2, write that again, over 3 to the power. Then you're going to times they together, okay? 2 times 2 equals 4, 2 times n is 2n, equal 3 to the power of 3. Then your next step is you're going to apply index law. When you divide and they have the same base, you're going to take away the power. So you're going to have 3 n minus 2, you write again, and then you take away the power here as 4 minus 2n, like that. Okay, equal 3 to the power of 3. So make sure you have one base on the left, one base on the right, so this one can go away. So you're left with just this equal to 3. So to simplify this, I'm going to break them down. So n minus 2, right, minus 4, and then minus and minus will become plus 2n equal 3. N plus 2n is 3n minus 6 equal 3. And you can solve for n, 3n equal 9. N equal 9 divided by 3 is 3. All right. Here we have pretty much the same example. So 5 and 25. So we go 25, you can make it 5 squared, can't you? So write that as 5 squared to the power of negative x plus 2. And then 5 to the power of 2x minus 4, write that on this side. So you would have 5 to the power of 2x minus 4 equal 2 times negative x is negative 2x. And then 2 times 2 equal 4. So once you have the base on the same on each side, you cancel the base out. So you're left with sorry, you're left with 2x minus 4. Let me just write this out, equal negative 2x plus 4. So what we do is we're going to move the plus 2x on this side and move the 4 over. We have, so we plug 2x here, plus 2x here. So we have 4x minus 4 equal 4. Then we move the 4 over by plotting 4. 4x equal 8. Then we divide it by 2, x equal 2. All right. These two examples are pretty much the same again. So if I have here, the base is 2 and make it 2 square and 16 make it 2 to the power 4. So I have 2n minus 1 times 4. You're going to write that as 2 square to the power of 2n plus 1 equals 16 make it 2 to the power 4. Then you expand it out. So 2 to the power 4n and then 2 times 1 equals 2. Okay, equal 2 to the power 4. Then you have times by 2 to the power n minus 1 here. Then index law, when you times and have the same base, you can add the power together. So 2 to the power n minus 1 plus 4n plus 2 equal 2 to the power 4. And once you've done that, 2 and 2 will cancel out themselves. N plus 4n is 5n. Negative 1 plus 2 is positive 1 equal 4. Then we have 5n equal, take the 1 over, 4 minus 1 is 3, then we divide it by 5, so n equal 3/5. Now, with this example, we're going to do the same strategy. As you can see, all the example here, we look at 27, we look at 3, 27, 3, and there's a times in between them. So we know that we can make them the same base of 3. So 27, we're going to make 3 cubed times by 3 to the power of n to the power of n equal 27 here. We make it 3 cubed, and then it's have n times by 3 to the power of 1/4. Okay, now index law, we have another index law here. If you have power and then you power again, you going to times them together. So you have 3 to the power of 3 times n is 3n, and then times by 3 to the power of n times n is n squared, right? Then you can combine these together. So when you times, you can add the power. So 3 to the power of 3n plus n squared, like that. Equal, then this one you expand out 3 to the power of 3n times 3 to the power of a quarter. Then you can add them. So 3 to the power of 3n plus 1/4. Okay. Once you have the base on the same side, you can get rid of them. Now you end up having this equal to this because I just write here 3n plus n squared equal 3n plus a quarter, sorry. So you have 3n and 3n on both sides. You can get rid of them as well. So you end up having n squared equal 1/4. N will be plus or minus root of 1/4, which is plus minus 1/2. All right, now, so this is the type of question where you can make them the same by. So the strategy for type 1 here is we just trying to convert all of them to the same by. There's another type in exponential equation, which is this type. We call that type 2. When you see there's a minus in between, or sometimes there could be a plus as well. And of course, you can't make them the same by. And you can see 9, 12, 3, 27. That's impossible, right? And there's a minus especially. So the strategy for this type is you're going to look and see if you look at this one here, 3x here. If you look at 9 to the power of x, if you do 3 square, you get 9. Right, so this general strategy, if we're going to let this equal I, so we let I equal 3 to the power of x. So if we let I equal 3 to the power of x, 9 to the power of x will become a square because 3 square equal 9. So we actually convert this to a quadratic equation. So 9 to the power of x, we're going to write that as a squared equal, we have 12 times a minus 27. So you actually convert exponential to a quadratic equation. Then you make one side equal 0, a squared minus 12a plus 27 equals 0. Then you would factorize this as a two numbers times together equal 27 and add together -9, which is negative 12, which is -9 and -3 equals 0. So you would have a equal 9 or a equal 3, right? Now, once you solve for a, then you put it back. Because you let a equal 3 to the power of x, then a here you replace as 3 to the power of x, and that's have to be 9. And same thing, replace a at 3 to the power of x equal 3. Then you can solve x. So 9 is 3 squared, right? So we can say x equal 2. And 3 to the power of x equal 3. So we know 3 to the power of 1. So 3 and 3 cancel out. So x equal 1. So we end up having two solutions. So this is the first example. And you can see the general strategy here is let the power equal a, and we convert to a quadratic equation. So pretty much the same thing here. So you see 3 to the power of x here, you let this equal a, then 3 to the power of 2x become a squared, greater than 2. So we have a squared equal 27 minus 6 times a. Move it over, so we have a squared plus 6a minus 27 equals 0. Factorize this, we would have plus 9 and -3. So we have a equal -9 or a equal 3. All right, once we solve for a, then we're going to replace a as 3 to the power of x. So we have 3 to the power of x equal -9 or 3 to the power of x equal 3. Now, 3 to the power of something equal a negative number, this is not possible. You can't have that. Okay, anything to the power of something, that's always a positive. 3 to the power of x equal 3, which means 3 to the power of 1, so you would have x equal 1. And so you have one solution here. So the general strategy for type 2 is when you see the plus or minus in between the term, as you can say, so you basically you let a equal, something to the power of x. So 3 to the power of x in this example, and then you convert to quadratic equation. Okay. And then you're going to solve a. When you solve for a, then you can solve for x from there. Now we come to another type, which is the convert that to logarithm. So sometimes it's not possible to make them the same base, or not possible to convert to quadratic. So I give you an example. So if I have 2 to the power of x minus 1 equal 9 or something, it's impossible to make to know 9 equal 2 to the power of something by hand. So what in this case we're going to convert to log. So what we do is we need to get rid of 2. So we're going to log 2 on both sides like that. So log 2 of 2 will go away themselves. So you have x minus 1 equal log 2 of 9. Okay. Then you just move the plus 1 over. So log 2 of 9 and then plus 1. So just symbol like that. All right. Same thing if I have a fraction 1/3 to the power of 2x minus 6 equal 4 something. So before you do anything, make 1/3 raise to the power of -1 because we like the base to be positive, to be bigger than 1, sorry. So make it like that. Then expand the amount, so raise to the power of -2x plus 6 equal 4. Now, to get rid of 3, you pretty much do the same thing. Like you're going to log 3 on both sides. So log 3 of 3 will cancel out. So you have negative 2x plus 6 equal log 3 of 4. Then move the 6 over, negative 2x equal log 3 of 4 minus 6. And then we divide it by negative 2. So x equal log 3 of 4 divided by negative 2 minus 6 divided by negative 2, which we can write that as, so the negative we put in the middle, so we write negative a half log 3 of 4, okay, and then negative 6 divided by negative 2 is 3. And finally, if you want to make it even nicer, see a half here, you can bring a half to the top, which means it's negative log 3 of 4 to the power of a half, which is 2. So you can write this as 4 to the power of 2. Sorry, log 3 of 2 plus 3. That's the nicest form.